What if the entire universe were made of patterns that repeat over and over again? This audiobook explores a concept as strange as it is fascinating, that the structures of the cosmos, galaxies, clusters, voids, might follow similar shapes on different scales, as if everything were designed with the same invisible rule. From the shape of a broccoli to the maps of the universe, nature seems to love repetition. But how much order repeats itself in the midst of chaos? And what does that tell us about how everything that exists is built? The answers reveal a surprising harmony and a mystery that still remains unsolved. Fractals are more than just visual images. They are a way of understanding the structure of the universe. I invite you to think about a snowflake. Every time we look at one, we realize that no two snowflakes are alike, but they all share a similar pattern. That is the essence of fractals, patterns that repeat at different scales, creating infinite and complex beauty. And what about the relationship between fractals and our everyday life? From the way leaves are distributed on a plant to the structure of clouds in the sky, fractals are everywhere. As we delve deeper into this topic, we will discover how fractals have influenced various disciplines, from biology to economics. Did you know that the growth patterns of certain plants can be mathematically described using fractals? This is not only amazing, but also gives us a new perspective on nature itself. And we won't stop there. We will discuss how these patterns also appear in financial markets. How is it possible that the economy, seemingly chaotic, can be represented by fractal patterns? The beauty of fractals is not limited to the scientific realm. Many artists have found inspiration in these forms. Have you ever wondered what a landscape created from mathematical formulas would look like? Throughout this journey, we will explore how fractals have changed digital art and given rise to new forms of creative expression. Animation and visualization are just the beginning. When talking about fractals, it is also essential to touch on the topic of chaos. What relationship exists between chaos and the ordered structure of fractals? This concept may seem contradictory, but often in chaos, we find patterns emerging from nothing. We will delve into this idea and see how understanding chaotic systems has led us to unravel the mysteries of the world. Technology has also been impacted by fractals, from image compression to algorithms that make our computers run more efficiently. Fractals have found their way even into the heart of modern computing. Can you imagine what our lives would be like without these patterns that optimize the functioning of our devices? As we progress, we will stop in the field of medicine. Medical research has begun to use fractals to better understand tumor growth and cellular distribution. This innovative approach opens up a range of possibilities in the fight against diseases. But what about our perception? Fractals also play a role in how we perceive beauty and art. Why are certain patterns more appealing to us than others? We will reflect on the philosophical implications of fractals, such as the notion of infinity and the very nature of the universe. This connection may seem abstract, but it invites us to question our understanding of the world. What does it really mean to be part of a fractal system in such a vast universe? Finally, we cannot forget the creation of fractals. Throughout this journey, we will learn how to generate these patterns using software and mathematical techniques. Imagine the satisfaction of creating your own fractal, a reflection of the complexity of the world around you. Fractals are, ultimately, a bridge between science and art, nature and technology. As we explore this topic, I hope you find inspiration and wonder in the complexity of the patterns that surround us. Get ready to discover a universe where mathematics becomes art and nature reveals its deepest secrets. Fractals are one of the wonders of mathematics, but what are they really? To understand this, let's think of something we all know, a snowflake. Each flake is unique, with an intricate design that seems to repeat at different scales. If we could observe a snowflake under a microscope, we would see that its patterns repeat at every level of detail. This idea of repetition at different scales is one of the most fascinating characteristics of fractals. Did you know that fractals are not just a mathematical concept, but they are present in many aspects of our everyday life? For example, if we look at a tree, each branch splits into smaller branches, and those branches also split into even smaller ones. This branching structure, which repeats at different sizes, is a perfect example of a fractal in nature. So, in essence, a fractal is a figure that repeats itself, no matter how close or far we are from it. But why are fractals so special? The answer lies in their mathematical properties. Fractals have a non-integer dimension, which means they do not conform to the traditional rules of geometry that we learn in school. It's as if we have a ruler that measures the length of an object, but as we get closer and closer, we discover that there are more details than we expected. This behavior challenges our intuition and invites us to think differently about space and shape. Often, fractals are associated with visual beauty. Why do you think that is? Imagine a beautiful mountainous landscape. When you look closely, you notice that the shapes of the mountains repeat in the hills and peaks. This repetition creates a sense of harmony and complexity, something that captures our attention and leaves us in awe. Every time we explore a fractal, we are discovering a new level of beauty and complexity. A famous example of a fractal is the Mandelbrot set. This set is so intriguing that it has become an icon of modern mathematics. Imagine drawing a point on a plane, then applying a simple mathematical rule and observing how that point transforms. By repeating this process, you obtain an astonishing pattern that seems endless. Each time you zoom in on a part of this pattern, you find new shapes and details that you had never seen before. This is what makes the Mandelbrot set so fascinating. Its ability to amaze and surprise those who dare to explore it. Fractals also teach us about complexity in simple systems. Let's think about how a small change in a mathematical rule can lead to completely different outcomes. This shows us that sometimes in life, the smallest decisions can have a huge impact. This connection between the simple and the complex is one of the most valuable lessons that fractals offer us. Nature provides us with countless examples of fractals. From the structure of a rosemary plant to the clouds in the sky, fractal patterns are everywhere. Observe a river winding through the landscape. Its path is full of forks and turns, each following a pattern that repeats at different levels. This type of design is not only beautiful, but also serves practical functions in the natural world. When thinking about fractals, it is fascinating to consider how these patterns can help us understand complex phenomena. For example, if we analyze the distribution of leaves on a tree, we can see that they follow a fractal pattern that maximizes sunlight capture. Thus, nature has found a way to optimize its resources through these mathematical designs. Speaking of the relationship between fractals and nature, have you ever wondered how it is possible for weather systems to behave so unpredictably? The answer may lie in the fractal structure of clouds and weather patterns. These patterns can help us predict the weather, providing a more effective approach to understanding the chaos that often seems to dominate the climate. An intriguing aspect of fractals is their application in art. Artists around the world have found inspiration in these complex and repetitive forms. From paintings to sculptures, fractals have influenced creatives from various disciplines, inviting reflection on the relationship between mathematics and aesthetics. Can you imagine how a simple equation can give rise to a visual masterpiece? With all this, it is evident that fractals are not just a mathematical phenomenon, but they are a gateway to a deeper understanding of the world around us. They invite us to explore, to question, and to marvel at the beauty of complexity. Each fractal tells a story, a narrative that connects mathematics, nature, art, and ultimately our own existence. So when you think of fractals, remember that they are everywhere, from the structure of a simple snowflake to the vastness of the universe. Each of these patterns is a reminder that beauty and complexity are integral parts of life, waiting to be discovered by those who dare to look closer. In the end, fractals teach us that despite apparent simplicity, there is always more to explore and learn. Fractals are a fascinating journey through mathematics and nature, but how did it all begin? The history of fractals is not just a timeline of discoveries, but a series of moments that changed our way of seeing the world. In the 20th century, a mathematician named Benoit Mandelbrot began to explore patterns that repeated at different scales. For him, shapes in nature were not simple. They were filled with complexities that challenged traditional mathematical beliefs. Imagine a snowflake. At first glance, it may seem like a simple figure, but if you look closely, you will discover that each flake is unique and has an intricate structure full of details. This is what Mandelbrot tried to capture. The idea that nature does not conform to the rules of order and simplicity, but is full of chaos and repetition. Thus, he began to study how these seemingly disordered shapes could be described mathematically. In 1975, Mandelbrot coined the term fractal from the Latin word fractus, which means broken or irregular. He was not only creating a new term, but giving voice to a concept that had been latent in mathematics for centuries. From Euclidean geometry, which deals with simple and clear shapes, to the complexities of fractal geometry, the evolution of mathematical thought took an unexpected turn. But why should we care? The answer is simple. Fractals are everywhere. From the way trees grow to the clouds in the sky, nature itself is designed in a fractal manner. Each branch of a tree splits into sub-branches, which in turn split into smaller branches, and so on. This branching pattern repeats at different scales, creating a visual and functional beauty that is hard to ignore. As Mandelbrot began to share his discoveries, the scientific community started to pay attention. In 1985, he published his most famous work, The Fractal Geometry of Nature. This book was not only a milestone in mathematics, but also opened the doors to a new way of understanding art and science. With his visual approach, he made complicated concepts accessible to everyone, allowing more people to delve into the world of fractals. As the theory of fractals expanded, intriguing questions began to arise. Can a simple pattern be the key to understanding complex phenomena? How can something as simple as an equation generate such beautiful and complex images? This is the mystery surrounding fractals, like a story unfolding in layers. Each discovery leads to new questions and explorations. Over time, fractals found their way into various disciplines. Biology, meteorology, economics, and even art were influenced by this new approach. In biology, for example, fractals help explain the distribution of leaves on a plant or the structure of the lungs, showing that nature often uses these patterns to optimize space and resources. The acceptance of fractals in the scientific community was not instantaneous. Many were skeptical, questioning whether these patterns really had practical relevance. However, as more studies were conducted and tangible applications were demonstrated, fractals began to earn a place in the heart of science. The ability to model natural phenomena accurately made them valuable tools for researchers in multiple fields. The story of fractals is also a story of perseverance and curiosity, despite initial resistance. Mandelbrot and other pioneers continued to explore, creating a legacy that still inspires today. In the end, it is not just about mathematics, but about how this mathematics can help us better understand the world around us. Looking back, it is fascinating to think about how a concept that started as a simple study of patterns has become a bridge between mathematics and nature. Fractals are not just geometric figures, they represent a way of seeing the world, a way to find order in chaos. As we explore more about fractals, we realize that each discovery brings us a little closer to understanding the complexity of life itself. The story of fractals is a reminder that sometimes what appears to be chaotic and disordered is, in fact, a reflection of a deeper order that we are just beginning to unravel. So the next time you admire a natural landscape or a piece of art, think about fractals and how these patterns have influenced our understanding of the universe. The story of fractals is not just the story of a mathematical discovery, but a journey into the beauty and complexity that surrounds us. And although the story of fractals began with a single question, it continues to open pathways to new and exciting explorations. Have you ever stopped to observe a tree? It's fascinating how its branches extend in multiple directions, creating a network of life that seems to repeat at different scales. This structure, where each branch resembles a miniature tree, is a perfect example of a natural phenomenon governed by fractal patterns. In nature, fractals are present in almost every corner of the world around us, and their beauty is a reminder of how the complex can arise from the simple. Did you know that mountains, with their peaks and valleys, also follow fractal patterns? When we look at a mountain from afar, we can see its contours, but as we get closer, we discover that every small landslide and every rock follows that same fractal shape. Each level of detail reveals more complexity, leading us to wonder, why does this happen in nature? The answer lies in how natural systems form and develop, where the same principles apply at different scales. Fractals are not just a mathematical curiosity, they play a crucial role in the functioning of many ecosystems. Imagine a river that branches into multiple tributaries. Each of these tributaries can be seen as a fractal, where the way water flows and distributes follows a pattern that repeats as we approach the source. This pattern not only helps us understand the flow of water, but is also vital for the life that depends on it. The formation of clouds is another impressive example. Clouds often form in structures that seem to dissolve and reconfigure constantly. As we observe how they group together, we can identify fractal patterns that show us how air and moisture interact in complex ways. These formations are not only fascinating to watch, they also help us predict the weather and understand changes in the atmosphere. When we look at the ocean, the surface of the water seems to be in constant motion. But if we analyze the waves, we notice that they also follow fractal patterns. Small waves group together and form larger waves, creating a visual spectacle that reminds us that nature is full of order amidst chaos. This phenomenon leads us to reflect on how nature uses these patterns to maintain balance in ecosystems. Have you ever marveled at the beauty of a snowflake? Each flake is unique, but they all exhibit symmetry and patterns that resemble fractal structures. The way they crystallize and develop is influenced by factors such as temperature and humidity, creating intricate geometries that may seem ordinary but are extraordinary at the same time. These flakes remind us that even the smallest things can contain a universe of complexity. Fractals are also found in the arrangement of leaves on a plant. This phenomenon, known as phyllotaxis, describes how leaves are distributed on a stem to maximize exposure to sunlight. This strategy, which seems simple, is based on fractal principles that allow plants to grow efficiently and adapt to their environment. Here, nature demonstrates once again that efficiency often lies in the repetition of patterns. But what about weather systems? Storms and hurricanes display structures that are clearly fractal. From the way clouds are organized to how winds are distributed, these phenomena are examples of how fractal patterns can help us understand complex climate events. Studying these structures is not only fascinating but also crucial for weather prediction and disaster mitigation. As we explore further, we find that even the distribution of stars in the universe follows fractal patterns. Galaxies cluster and disperse in a way that reflects the same complexity we see in nature. This discovery raises profound questions about order and chaos in the cosmos, taking the idea of fractals beyond our planet and into the stars. The interconnection of fractals in nature invites us to consider how all these patterns are related. From the way a tree grows to how galaxies form, each fractal is a thread in the vast web of life. This understanding helps us appreciate the beauty of the natural world and recognize that, despite its complexity, everything is interconnected. So the next time you observe a landscape, a river, or even a snowflake, remember that you are looking at a fractal in action. What may seem simple at first glance carries with it a rich and complex story, where every detail matters. Nature, with its repetitive patterns and intricate beauty, teaches us that the extraordinary can be found in the everyday, and that ultimately we are all part of this amazing fractal design. Fractals offer us a unique perspective on the world. They remind us that there is beauty in repetition, and that even in what seems to be chaos, there is order. This revelation is not only a visual delight, but also invites us to explore and understand more deeply the environment around us. With each discovery, we get a little closer to unraveling the mysteries of life itself. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Fractals have found their way not only into mathematics and science, but also into art, revealing a deep connection between aesthetic beauty and mathematical complexity. What do an abstract painting and a Mandelbrot set have in common? Both are spaces where repetition and variation intertwine to create something truly astonishing. Fractals offer us patterns that seem never-ending and often reflect the very nature of reality. The relationship between fractals and art is not limited to the visual. The essence of fractals lies in their ability to capture attention and provoke emotions. When an artist immerses themselves in the world of fractals, they are exploring a visual language that goes beyond the conventional. Have you ever felt drawn to an image that seems to contain a universe within it? That's what fractals can do. They invite contemplation and endless exploration. When talking about fractal art, it's fascinating to think about how these patterns repeat at different scales. Just like a tree that branches out, where each branch resembles the structure of the tree as a whole, fractal art reflects an intrinsic relationship between the whole and the parts. This idea of self-similarity is not only a mathematical principle, but also manifests in the creativity of artists. Digital artists have found in fractals a powerful tool for creating stunning visuals. With specialized software, they can generate images that challenge perception and play with imagination. Can you imagine creating a landscape that extends infinitely, where each section is a masterpiece in itself? That is the magic of fractal art, the possibility of creating without limits. In music, the influence of fractals is also palpable. Composers have begun to use fractal patterns in the structure of their pieces, creating melodies that repeat and evolve, similar to the forms of nature. Have you ever wondered what a fractal sounds like? The answer may be surprising. It is a symphony of repetition and variation, where each note finds its place in the overall structure, just like a fractal on the canvas. Fractals have also inspired traditional visual artists who have used their principles to explore new forms of expression. Works of art that emulate the complexity of fractals can evoke a visceral connection with the viewer. What emotions do the shapes that seem to extend infinitely awaken in you? This emotional connection is one of the reasons why fractal art has captured the imagination of so many. In photography, fractals can be observed in the structure of many elements of nature, from clouds to mountains. The repetition of fractal patterns creates a visual balance that is captivating. A photographer who understands these principles can capture the essence of nature in a way that goes beyond the superficial. How can a simple tree reflect the complexity of the universe? The answer lies in its fractal design. Fractals have also been used in animation and film, where artists have created entire worlds based on these structures. Imagine a landscape where every small detail is a miniature version of what lies on the horizon. This technique is not only visually impressive, but also offers an immersive experience for the audience. The idea of a fractal universe becomes a metaphor for the human experience itself, always in search of new perspectives. The popularity of fractal art has led to the creation of communities and platforms where artists can share their works and techniques. This exchange not only fosters creativity, but also allows the concept of fractals to expand and evolve. Who knows what new forms of art will emerge from this fusion of mathematics and creativity? In the end, fractal art is not just a branch of art, but a movement that challenges our perceptions and invites us to reflect on the nature of beauty. It shows us that complexity can arise from simplicity and that in repetition lies an inexhaustible source of creativity. What if we began to see the world through the lens of fractals, seeking patterns and connections in everything around us? The next time you observe a piece of fractal art, I invite you to ask yourself, what story does it tell? How does it reflect the complexity of life itself? Fractals are more than a subject of study. They are a way of seeing the world around us, a reminder that beauty can be found in the most unexpected places. So, are you ready to explore this fascinating universe more deeply? There is much more to discover at the intersection of art and mathematics, where each fractal offers us a new window into understanding our existence. The quest for beauty through fractals is ultimately a quest for ourselves. Fractals are a fascinating phenomenon that lies at the heart of mathematics. But what does that really mean? To understand it, we first need to talk about patterns. Imagine you are looking at a snowflake. Each one is unique, but they all have a similar structure, a design that repeats at different scales. This repetition is one of the key characteristics that define fractals. In the world of mathematics, fractals are more than just patterns. They are shapes that repeat infinitely, revealing astonishing complexity as we delve deeper into them. One of the most emblematic examples of fractals is the Mandelbrot set. But what exactly is this? Visualize an image that seems simple at first. However, as you zoom in, you discover more and more details. Isn't it impressive? Each part of the Mandelbrot set is a miniature of the whole. A kind of mirror that reflects the same complexity, no matter how close or far away you are. This phenomenon is called self-similarity, and it is one of the cornerstones of the study of fractals. The beauty of fractals doesn't stop at mathematics. In fact, these patterns have found their way into art. Digital artists have used fractal algorithms to create stunning works that challenge our perception of reality. But why are they so captivating? The answer may lie in the way our brain processes visual information. Fractal shapes tend to be more appealing to us, perhaps because they resonate with the very nature of our environment. Now, delving a little deeper into the mathematical realm, we find that fractals are linked to complex equations that may seem intimidating at first glance, but there is no need to be scared. Imagine you have a cooking recipe. The equation is like that recipe. Follow the steps and you will get a delicious result. In the case of fractals, the result is a shape that can be as simple as a triangle or as complicated as a mountainous landscape. The magic lies in how a simple rule can generate an infinite variety of shapes. One of the questions that arises is, what makes fractals distinct from other geometric figures? The answer lies in their dimensionality. Unlike a circle or a square, which have well-defined dimensions, fractals blur those lines. They have fractional dimensions. They can have a length that seems infinite, even in a limited space. This may sound complicated, but it is similar to how a river can seem to have a longer course as you follow its meanders instead of measuring the distance in a straight line. Fractals also play a crucial role in the study of dynamic systems. Imagine a swinging pendulum. As you observe it, you may notice patterns in its movement. Mathematicians use fractal concepts to describe these patterns and better understand how certain systems can behave in unexpected ways. It's as if by breaking down the movement into smaller parts, we could predict its overall behavior. But what about fractals in the real world? They are often thought to be mere mathematical curiosities, but they have significant practical applications. From image compression on our devices to computer graphics creation, fractals are at the core of many modern technologies. Have you ever wondered how so many images can be stored in such a small space? Fractal algorithms make this possible by optimizing data without losing quality. The relationship between fractals and nature is another fascinating area. Fractal patterns are ubiquitous in the natural world. From the way trees branch out to the structure of river systems, nature seems to follow a fractal design. Every leaf of a plant, every mountain, every cloud has something to do with fractal geometry. Isn't it amazing to think that what we see around us may be governed by these same mathematical rules? Another intriguing question is, how do fractals relate to chaos? This is a concept that may seem contradictory. Fractals, despite their order and beauty, can also arise from chaotic systems. Imagine a weather system. Although it may seem disorderly, fractal patterns can help model and predict climate changes. This leads us to explore the connection between chaos and predictability. In the realm of biology, fractals also play an essential role. Biological structures, such as lungs or the branching of veins, exhibit fractal patterns that optimize space and functionality. By understanding these structures through the lens of fractals, scientists can gain valuable insights into their functioning and potential medical treatments. Finally, it is worth reflecting on the aesthetic impact of fractals. The beauty of a fractal lies not only in its structure, but in how it invites us to explore and discover. They challenge us to look beyond the surface and find complexity in simplicity. This reminds us that, at its core, mathematics and art are intertwined and that fractals are a bridge between both worlds. A reminder that beauty can arise from patterns that repeat and transform. So, as we explore the fascinating mathematics behind fractals, we are not just discovering figures and shapes, we are delving into a world where structure, beauty, and complexity meet, showing us that mathematics is not just numbers and equations, but a way to understand the universe in all its magnificence. When we think of modern technology, we often imagine sleek devices and sophisticated software. But have you ever considered how mathematics, especially fractals, is behind many of these innovations? The connection between fractals and technology is much deeper than we might imagine. These complex patterns are not only fascinating from an aesthetic point of view, but they are also powerful tools in the digital world. Fractals, those beautiful patterns that repeat at different scales, have found their place in image compression. Have you ever wondered how it is possible to send high-quality photographs and videos over the internet without taking up so much space? The answer lies in how fractals allow us to describe images. Instead of storing every detail of an image, fractal patterns can be used to represent information more efficiently. This means that when compressing an image, rather than losing quality, repetitive elements can be identified and stored, making the file smaller. In addition to image compression, fractals also play a crucial role in computer graphics generation. Creating virtual worlds and scenarios in video games requires an immense amount of visual data. This is where fractals come into play, helping to create realistic landscapes without the need to model each tree, rock, or mountain individually. By using mathematical rules based on fractals to generate these elements, developers can create environments that appear vast and natural but are actually much simpler to produce. The use of fractals is not limited to visual aesthetics. In computing, they are also applied in algorithms that help solve complex problems. For example, fractals can be used in data searching, allowing computers to find patterns in large sets of information more quickly and efficiently. Thus, these patterns not only beautify but also optimize system performance. In the field of simulation, fractals are essential tools. Imagine you want to simulate the growth of a plant or the development of a cloud in an animation program. Instead of having to draw each leaf or each drop of water, fractals allow designers to use mathematical formulas that replicate natural growth. This not only saves time but also produces more realistic results. Virtual reality technology has also embraced the concept of fractals. To create immersive experiences, it is crucial that the environment feels authentic. Fractals, with their ability to generate complex structures from simple rules, are used in creating virtual worlds that are surprisingly detailed. This allows users to immerse themselves in experiences that feel truly real. Now, what about music and fractals? Surprisingly, fractals have also found their way into musical composition. Some composers use fractal patterns to create musical structures that repeat and evolve, offering an auditory experience that plays with our perception of rhythm and melody. Generative music, which is based on fractal algorithms, can produce pieces that are unique with each listen, keeping the listener always intrigued. Artificial intelligence and machine learning also benefit from fractals. Algorithms that mimic the way humans learn can be optimized using fractal principles. This means that by understanding how data is structured, more accurate and efficient models can be developed. The inherent symmetry and repetition of fractals allow machines to recognize patterns in a way similar to how we do. The applications of fractals in technology do not stop there. In medicine, for example, they are being used to model cell distribution and understand tumor growth. Fractal patterns can reveal information about how certain diseases spread or how the body responds to treatments. This opens a promising path toward advances in medical research and personalized therapies. It is amazing to think about how something as abstract as a fractal can have so many practical applications in our daily lives. From the way we navigate the internet to how we enjoy a video game or a piece of music, fractals are woven into the fabric of modern technology. In a world where efficiency and aesthetics are fundamental, fractals offer us a way to harmoniously unite both aspects. The next time you look at a digital image or play a video game, remember that behind those stunning graphics lies a mathematical complexity that makes everything work. Fractals are not just a visual phenomenon, they are the language of technology, a tool that helps us understand and explore the world around us. In this digital age, their relevance will only continue to grow, and the possibilities they offer are as infinite as the fractals themselves. Fractals are not only a mathematical wonder, they are also at the heart of the life that surrounds us. Have you ever noticed the shape of a tree? Its branches unfold in patterns that, although they seem random, follow a surprising natural order. This branching pattern repeats over and over, from the root to the tip of each branch. In nature, fractals are the rule, not the exception. The leaves of ferns are another excellent example. Observe how each leaf is made up of small leaflets that in turn resemble the whole leaf. This efficient design allows the plant to maximize sun exposure and water capture. Each small component reflects the overall shape, creating a framework that is both simple and complex. This is not only beautiful, it is functional. What about mountains? At first glance, they may seem huge and solid, but if we look closer, we discover that their surface is filled with peaks and valleys that repeat on smaller scales. This fractal structure helps us understand how the forces of nature have shaped our planet over millions of years. Mountains are not just large, they are an organized system of geological patterns. The ocean also reveals its fractal nature. When we look at the coastlines, we notice that their shape is not smooth or uniform. Rather, it is full of inlets and outlets, and if we observe more closely, those details repeat on smaller scales. This complexity translates into a rich marine ecosystem where every nook harbors life. The ocean thus becomes a vast fractal canvas. What role do fractals play in the climate? The answer is fascinating. Weather patterns, such as hurricanes, exhibit fractal characteristics. The way they develop and expand is very similar to the patterns we see in the growth of a tree or in the structure of a cloud. This means that by studying these phenomena, we can apply what we know about fractals to predict weather behaviors, helping us prepare for what is to come. In the biological realm, we find fractals in unexpected places. For example, the human circulatory system is an intricate fractal design. Arteries and veins branch into smaller and smaller vessels, ensuring that every cell in our body receives oxygen and nutrients. This efficient geometry maximizes blood flow, a phenomenon that is repeated in many living organisms, from the simplest to the most complex. Another manifestation of fractals in biology is observed in the lungs. The structure of the alveoli, where gas exchange occurs, is organized in a fractal manner, allowing for a large surface area within a relatively small space. This efficiency is crucial for respiration, a vital process that sustains life. Fractals are also found in the arrangement of leaves on a plant, a phenomenon known as phyllotaxis. The way leaves are organized on a stem follows mathematical patterns that optimize sunlight capture and minimize the shadow that one leaf can cast on another. This fractal design is not only beautiful but also an example of how nature uses mathematics to survive. Are fractals just a curiosity of nature, or do they have a deeper role in our understanding of the world? As we explore these patterns, we discover that they help us understand the complexity of natural systems. Nature has perfected these designs over millions of years, and we, as observers, are just beginning to unravel their secrets. The beauty of fractals lies in their ability to unite the simple with the complex. In every branch of a tree, in every leaf of a fern, and in every biological structure, there is a tale of adaptation, survival, and beauty. These patterns remind us that, despite the apparent randomness of life, there is an underlying order that connects everything. The next time you observe a tree, a leaf, or even a storm, remember that you are witnessing fractals in action. These patterns are not only visually impressive, but also essential for understanding natural processes. Fractals teach us that nature has its own language, one that is full of symmetry and repetition. Every time we delve into the study of fractals in biology, we come one step closer to deciphering the code of life. Understanding how they function and how they manifest in our environment helps us appreciate the extraordinary complexity of the natural world. Fractals are undoubtedly a window into the mysteries of nature and our own existence. So the next time you encounter a repetitive pattern in nature, take a moment to admire its beauty and complexity. Fractals are not just a mathematical curiosity, they are an integral part of life itself, connecting everything in a beautiful and harmonious design that spans from the infinitely small to the colossally large. Chaos. That word can evoke images of disorder and confusion, but interestingly, it is also a fascinating concept that intertwines with the beauty and complexity of fractals. What if I told you that chaos is not just disorder, but can also be a pattern, an art form in itself? The relationship between chaos and fractals is deep and astonishing, and today we will explore how these concepts are interwoven. Imagine a flowing river. At first glance, it may seem that the water moves randomly, zigzagging aimlessly. However, if you look closely, you will notice that there are patterns in how the water flows. These patterns are the result of a series of interacting factors, creating a system that, although chaotic, has its own internal logic. This is how chaotic systems work in nature. They are unpredictable, but also surprisingly ordered. Fractals, on the other hand, are structures that repeat at different scales. This property, known as self-similarity, allows fractals to be found in unexpected places, from the shape of a cloud to the structure of a snowflake. But why is this relationship between fractals and chaos important? The answer lies in how fractals can help unravel the complexity of chaotic systems. Consider a climate system. The Earth's atmosphere is a chaotic place, filled with complex interactions between temperature, pressure, and humidity. These factors combine to create phenomena like storms and hurricanes. Fractal models have proven useful for understanding these climate patterns, as they can describe how different elements are distributed and related in this chaotic environment. Isn't it incredible to think that by studying fractals we can gain insights into the climate around us? Often chaos makes us feel insecure, but it can also lead us to a new level of understanding. In chaos science, we find that small changes in initial conditions can have drastic effects on the final outcome. This concept, famous for the butterfly effect, reminds us that even the flap of a butterfly's wings in one part of the world can, theoretically, trigger a tornado in another. This idea shows us that chaos can be at the heart of the creation of fractal patterns. The relationship between chaos and fractals is not limited to nature. It also extends to art and music. How can musical compositions be related to chaos? Some musical works are built on repetitive patterns that, although they seem simple, can create a complex and rich auditory experience. Thus, fractals can be seen as a metaphor for creativity, where repetition and variation give rise to unexpected beauty. In the realm of biology, fractals also find their place. Biological systems often exhibit fractal patterns, from the branching of blood vessels to the structure of the lungs. This self-similarity in biology is an example of how the principles of chaos and fractals can be essential for understanding life itself. Every cell, every tissue reflects an order amidst biological chaos. Returning to mathematics, chaos theory has allowed scientists to model complex and seemingly random behaviors using simple equations. Surprisingly, this means that chaos is not just a phenomenon to be observed, but can also be predicted to some extent. Fractals are a powerful tool in this sense, as they can help visualize and understand these chaotic behaviors. It is astonishing to think about how chaos and beauty can coexist in the same space. Fractals show us that although the world may seem chaotic and disorderly, there are hidden patterns and structures waiting to be discovered. This duality between chaos and order is one of the great wonders of our universe. The exploration of chaos and fractals also has philosophical implications. It leads us to question our perception of reality and how we interpret the world around us. If chaos can be a source of order, what does that mean for our understanding of the universe and our own existence? Perhaps not everything in life follows a linear path. Often there are unexpected twists that can lead us to new and exciting directions. The fascination with fractals and chaos does not stop here. As we move into the future, research in these areas continues to expand, providing new opportunities to discover patterns in areas we once considered chaotic. From economics to medicine, the principles of fractals are being applied to unravel the complexity of the systems we are immersed in. So, the next time you face something that seems chaotic or disorderly, remember that there may be an underlying order waiting to be discovered. Fractals teach us that even in chaos, there is beauty, patterns, and connections that can enrich our understanding of the world. The dance between chaos and fractals is a reminder that, in the complexity of life, there is always something deeper to explore. The relationship between fractals and climate is as fascinating as it is surprising. Have you ever wondered how a small change in temperature can trigger a series of climatic events that affect an entire continent? This complexity can be better understood by observing the world of fractals. In nature, fractal patterns repeat at different scales, and this property is crucial for understanding how climate systems function. Climate systems are, in essence, chaotic entities. This means they are very sensitive to initial conditions. A simple flutter of a butterfly's wings in Brazil, for example, can theoretically trigger a hurricane in Texas. This concept, known as the butterfly effect, reminds us that, as in fractals, the small can have a huge impact. But how exactly are fractals related to these climatic patterns? Modern climate models use fractal concepts to represent the complexity of the atmosphere. These models are not simple straight lines. Instead, they reflect the intricate nature of meteorological phenomena. Imagine a map of a city. If you draw the streets directly, you might get lost. However, if you consider the curves and turns of the streets, you will have a better idea of how to navigate. This is how scientists use fractals to represent the atmosphere and its dynamics, allowing for a better understanding of how the climate can change. Rain, for example, does not fall uniformly. One might think it is just water falling from the sky, but in reality its distribution follows fractal patterns. Some areas receive torrential rains, while others may remain completely dry. This non-random behavior can be modeled using fractal theories, helping to predict where and when floods might occur. Moreover, clouds themselves are an example of fractals in action. Their shape and distribution can be incredibly complex, with details that repeat at different scales. Observe a cloud from a distance and you will see a general shape, but as you get closer, you will notice that it has smaller structures resembling its overall shape. This repetition is a key characteristic of fractals and is fundamental to understanding how clouds form and move in the sky. When it comes to hurricanes, the relationship with fractals becomes even more evident. These imposing meteorological phenomena have shapes that can be mathematically described as fractals. Their internal structure, with bands of clouds swirling around a central eye, can be analyzed using fractal theories, allowing meteorologists to predict their trajectory and possible impacts. Wind patterns are also fertile ground for the study of fractals. Winds do not move in straight lines. Instead, they flow in complex and twisted patterns. Scientists have found that by applying fractal concepts to wind simulations, they can obtain a more accurate representation of how air behaves under different climatic conditions. This not only helps predict the weather, but is also essential for aviation and maritime navigation. But what about long-term climate changes? Fractals come into play here as well. Variations in global temperatures, droughts, and precipitation patterns can be better understood by observing their fractal behavior. By analyzing this data, scientists can identify cycles and trends that would otherwise go unnoticed. This is crucial for future planning in agriculture, water management, and disaster prevention. Another interesting aspect is how fractal theories can help study extreme phenomena, such as severe storms or prolonged droughts. These situations may seem random, but by breaking them down into fractal patterns, researchers can find similarities and predict these events. It's like trying to solve a puzzle. By looking at the smaller pieces, you can start to see the bigger picture. The ability to model the climate using fractals also has important implications for sustainability as we face climate change. Understanding these patterns becomes vital for developing strategies to mitigate its effects. By understanding how fractals influence our climate, we can better prepare for the future and make informed decisions about resource use and environmental conservation. Fractals teach us to see the world differently. Instead of thinking of the climate as something fixed and predictable, they show us that it is a dynamic system, full of interconnections and patterns. This understanding allows us not only to anticipate the weather, but also to appreciate the beauty of nature in all its complexity. As we delve deeper into the connection between fractals and climate, it is essential to remember that although the climate may seem chaotic and random, there is an underlying order that we can learn to understand. This connection invites us to respect and care for our environment, recognizing that every small action can have an impact in the grand scheme of things. Finally, the relationship between fractals and climate offers us a broader perspective on how we interact with our planet. It reminds us that, just like in a fractal, each of us is a part of a much larger whole, and by better understanding the patterns that surround us, we can work together towards a more sustainable and harmonious future. In the vast world of economics, where figures and trends often seem to blur and complicate, a fascinating question arises. Is it possible that there is a hidden pattern behind the chaos of financial markets? The answer leads us to explore the surprising connection between fractals and economics. Fractals, those complex and beautiful patterns that repeat at different scales, offer a new way to understand how markets operate. When thinking about economics, it is common to imagine linear graphs that rise and fall. However, what if I told you that instead of following a straight line, markets may behave more like a mountainous landscape, full of peaks and valleys? This fractal view of economics allows us to see that, although the market may rise one day, it could fall drastically the next, and vice versa. This erratic behavior is not just random. It has an underlying structure that can be analyzed. Fractals in economics are based on the idea that investor behavior patterns can be replicated at different scales. For example, what happens in a day may resemble what occurs in a month or even a year. This leads us to wonder, can we predict the future of the markets if we understand these patterns? The answer is intriguing because while we cannot predict with certainty, we can identify trends that help us make more informed decisions. Another fascinating aspect is how fractals allow us to visualize volatility. When we observe a price chart, it sometimes seems that there are random movements. However, by applying fractal theory, we begin to notice that these fluctuations have a certain regularity. Like a calm sea that suddenly becomes agitated, financial markets can be calm one moment and turbulent the next, but always following an underlying pattern. Chaos theory also plays a crucial role in this relationship. Who hasn't felt that a small event can trigger a chain reaction in the market? This is exactly what chaos theory tells us. Small variations in initial conditions can lead to completely different outcomes. In the context of economics, this means that an apparently insignificant piece of news could cause a company's stock to rise or fall significantly. One of the pioneers in applying fractal theory to economics was Benoit Mandelbrot. Known for his work in the field of fractals, Mandelbrot suggested that markets are not efficient, as previously believed, but are inherently unpredictable and chaotic. This changed the way economists and financial analysts view market movements. Instead of seeking a perfect model, they now focus on understanding the complexities and patterns that arise from human interaction. By understanding fractals, investors can develop more effective strategies. For example, a trader might observe how certain stocks behave in a short time frame and from there extrapolate patterns that may be useful in the long term. This ability to see beyond the immediate and recognize broader trends can make the difference between a successful investment and a failure. Moreover, fractals are not limited to price charts. They can also be applied to other aspects of economics, such as consumer behavior. People's purchasing decisions often follow patterns that can be analyzed similarly to market movements. This opens the door to a deeper understanding of how and why we make economic decisions. However, it is important to remember that while fractals offer a fascinating way to analyze economics, they are not a magic formula for predicting the future. Economics is a field full of uncertainties and unforeseen variables. Still, the fractal perspective provides us with valuable tools to navigate this complex world, helping us understand that chaos can have a hidden order. The use of fractals has also extended to the creation of more accurate economic models. Through simulations that replicate fractal patterns, economists can attempt to predict how markets will behave in different scenarios. This not only helps investors, but also provides useful insights for economic policy formulation. As we move toward an increasingly digital and connected future, the application of fractals in economics is sure to continue growing. Emerging technologies, such as artificial intelligence and machine learning, are beginning to integrate fractal concepts into their algorithms, which may offer new opportunities to analyze and predict market behavior. A particularly inspiring aspect of this connection between fractals and economics is that it reminds us that, ultimately, we are trying to understand human behavior. Every investment decision, every purchase, and every sale is the result of emotions and reactions that may be more predictable than we think if we manage to look beyond the surface. In conclusion, the relationship between fractals and economics is an intriguing reminder that, even in a realm that often seems chaotic and disorderly, there are patterns we can study and understand. This fractal perspective not only provides us with a new way to analyze markets, but also invites us to reflect on the very nature of uncertainty and complexity in which we live. As we continue to explore this fascinating topic, it becomes clear that fractals have much to teach us about the world around us and the role we play in it. Music, that universal language that transcends borders, has a surprising connection with fractals. But how do these two seemingly different disciplines intertwine? To understand this, it is essential to explore how fractal patterns can be found in the very structure of the music we listen to. From the melodies that move us to the rhythms that make us dance, fractals offer a unique way to understand musicality. Fractals are patterns that repeat at different scales, and similarly, music is also built from rhythmic and melodic patterns. Have you ever noticed how a simple melody can expand into a full symphony, where the same motifs develop and transform over time? This phenomenon can be seen as a fractal dance, where each variation of the melody is like a new sprout from a tree, maintaining its essence but growing in different directions. Let's think about classical music. Composers like Johann Sebastian Bach are masters in the use of repetition and variation. In his fugues, for example, patterns can be found that repeat and transform, similar to how a fractal unfolds in nature. The structure of a fugue is comparable to a musical fractal. It starts with a theme that develops and is presented in different keys, creating a complex network that is both beautiful and astonishing. Now, if we delve into the world of contemporary music, we find that many artists experiment with the idea of fractal repetition in different ways. Have you ever wondered why electronic rhythms are so hypnotic? Many of these rhythms use patterns that repeat and gradually transform, just like a fractal where each part contains the essence of the whole. In electronic music, every pulse and every melodic line contribute to creating an immersive sonic experience. The connection between music and fractals also extends to algorithmic composition, where composers use algorithms to create music. These algorithms can follow principles similar to those of fractals, generating melodies that develop in infinite and complex ways. Imagine a composer who, like a fractal artist, sets simple rules and lets the music grow organically. The result can be a masterpiece, full of surprising variations that never repeat exactly the same. In this context, music becomes not only a form of art, but also a mathematical exploration. Through this fusion, musicians can create soundscapes that reflect the complexity and beauty of the fractals present in nature. From the murmur of a river to the singing of birds, all these sounds can be considered fractals in themselves, as they possess repetitive structures and patterns that manifest in different ways. Fractal aesthetics can also influence how we perceive music. Studies have shown that music incorporating fractal patterns can evoke deeper emotional responses in listeners. Why does this happen? The repetitive and self-similar nature of fractals can resonate with our emotions, creating a sense of familiarity and connection. Thus, when listening to music that follows these patterns, we may experience a richer and more meaningful experience. Music is not the only realm where fractals appear. In the world of music visualization, fractal images can be used to graphically represent music. Imagine seeing a series of geometric patterns unfolding while you listen to your favorite song. This combination of sound and visualization can result in an immersive experience, where fractals are not only heard but also seen, creating an even stronger bond between music and visual art. And what about compositions that are directly inspired by fractal theory? Some contemporary composers have created pieces that, like fractals, challenge traditional structures of music. These works may seem chaotic at first, but like a fractal, they reveal an underlying order that invites deeper listening. Through this exploration, the listener becomes an explorer, discovering new layers and dimensions in the music. The relationship between music and fractals also leads us to question the nature of sound itself. After all, music is just a series of sound waves that propagate through the air. But what shape do these waves take? Like fractals, they can be complex and beautiful, with patterns that repeat and transform as they travel. This idea reminds us that music is a tangible manifestation of the fractal principles that govern our universe. When we consider the future of music and fractals, it is exciting to imagine how technology will continue to enable new forms of composition and experimentation. Artificial intelligence and advanced algorithms are opening doors to new creative possibilities. What new sounds and fractal patterns await us on the musical horizon? The intersection of science, art, and technology promises to take music to new dimensions where creativity can flourish in ways we have yet to imagine. At the end of the day, the connection between music and fractals invites us to reflect on how we perceive the world. The patterns we find in nature, in music, and in our daily lives are a reminder that everything is interconnected. By exploring these links, we not only expand our understanding of music, but also deepen our appreciation for the beauty and complexity of the universe that surrounds us. Fractals have found a special corner in the world of computing, becoming fundamental tools that have changed the way we understand and visualize the digital world. But what makes fractals so valuable in modern technology? To understand this, one must imagine a digital landscape that, like a fractal, repeats and transforms at different scales. This ability to replicate and adapt is what makes fractals an incredibly powerful resource in the realm of computing. One of the first aspects that comes to mind when talking about fractals in technology is the creation of computer graphics. Have you ever marveled at a digital image so rich in detail that it seems infinite? The reason behind this astonishing visual quality lies in the mathematics of fractals. Thanks to them, designers can create landscapes, textures, and shapes that appear realistic and at the same time are incredibly efficient in terms of data storage. Instead of having to store every tiny part of the image, the pattern is stored and reproduced at different scales, as if you had a canvas that paints itself. But how does this translate into something we can all understand? Imagine you have a puzzle. Instead of having to store each piece individually, you have an image of the complete picture and can reconstruct it at any time. This is what fractal algorithms do in the digital world. They allow graphics to be generated from simple mathematical instructions, saving space and time. Animation is another field where fractals shine. Have you noticed how some movies and video games present vast and complex worlds? Thanks to fractals, developers can create landscapes that extend infinitely. Imagine a mountain landscape that never seems to end. This is possible because by using fractal patterns, mountains and valleys are generated that appear natural and extend beyond what the eye can see. However, the influence of fractals is not limited to graphics and animation. In the field of simulation, fractals allow for more realistic modeling of natural phenomena. For example, when simulating weather or plant growth, fractal algorithms are used to replicate how they develop in nature. This provides results that are not only visually appealing but also scientifically accurate. Moreover, fractals are also essential in data compression. Have you ever wondered how high-quality images can be sent over the internet without taking up so much space? This is where fractals come into play again. Through fractal-based compression techniques, it is possible to reduce the size of images while maintaining their quality, resulting in faster and more efficient data transmission. It's like having a music file that, although smaller, sounds just as good as the original. Virtual reality has also found an ally in fractals. In this field, virtual environments can be designed to appear more immersive and detailed. Fractal algorithms help create textures and elements that respond to user interaction, making the experience richer and more engaging. In a way, fractals allow virtual reality to feel more real. Now, when we talk about algorithms and computing, we cannot forget the importance of fractals in artificial intelligence. Neural networks and other machine learning systems utilize principles that can be related to the self-similarity of fractals. This means that, like a fractal, these systems can learn and adapt to different levels of complexity, improving their performance over time. But what about cybersecurity? Fractals also play an important role in cryptography. As more complex methods are developed to protect information, the mathematics behind fractals offers new ways to secure data and communications. In this context, fractals become a shield that protects our information in an increasingly digital world. We cannot overlook the applications in data analysis. In the information age, fractals are useful for visualizing patterns in large volumes of data. For example, when analyzing financial market behavior, fractal patterns can help identify trends and predict movements, becoming valuable tools for analysts. Finally, as technology advances, research on the use of fractals continues to expand. New applications are continuously emerging, and it is fascinating to imagine how these complex patterns will continue to influence our digital lives. From creating graphics to encoding data, fractals are an integral part of the fabric of modern technology. In summary, fractals are much more than simple geometric figures. They are powerful tools that have transformed the world of computing. From creating graphics to simulating environments, their impact is vast and profound. By understanding the beauty and complexity of fractals, we can also appreciate their essential role in the development of the technology we use every day, opening the door to a future full of infinite possibilities. The fascinating world of fractals is not only found in mathematics, art, or nature, but it also plays an essential role in the field of medicine. But how is it possible that seemingly abstract and complex patterns can have such vital applications in human health? The answer lies in the way fractals describe and model biological structures, revealing secrets about how our bodies function. Biological structures are not simple and linear. Instead, many of them exhibit behavior that resembles fractals, where the same shape repeats at different scales. A clear example of this is the human respiratory system. The lungs, in their intricate network of bronchi and alveoli, resemble a tree where each branch divides into smaller branches, and so on. This configuration allows for the maximization of the surface area for the exchange of oxygen and carbon dioxide, something essential for our survival. Isn't it amazing to think that the design of our lungs follows patterns that mathematicians have studied for decades? In addition to the lungs, fractals also appear in the distribution of cells. If you observe biological tissue, you will notice that cells are not distributed evenly. Instead, their arrangement may follow fractal patterns. allowing them to interact more efficiently. This is crucial in processes like wound healing, where cells must organize themselves to close a wound in the best possible way. Who would have thought that the way our cells are organized could be governed by mathematical patterns? Research in medicine has begun to leverage this relationship between fractals and biology. For example, scientists have used fractal models to study tumor progression. When a tumor grows, it does not expand uniformly. Instead, its shape and distribution can be described using fractal ideas. By understanding these patterns, doctors can predict how a tumor will behave and consequently develop more effective treatments. Isn't it fascinating how mathematics can help save lives? On the other hand, fractals have also been used in medical imaging. Techniques like magnetic resonance imaging and computed tomography generate images of the inside of the human body, and fractal algorithms can enhance the quality of these images. This means that doctors can see more clearly and accurately, allowing them to make more precise diagnoses. So the next time you think about a medical scan, remember that there is a bit of fractal mathematics behind that revealing image. One of the most exciting applications of fractals in medicine is in research on mental health. Recent studies have shown that fractal patterns in nature can influence our psychological well-being. This has led to the creation of therapies that incorporate natural environments, where patients are exposed to landscapes containing these patterns. The idea is that the fractal beauty of nature can have a calming effect on our minds, helping to reduce stress and anxiety. Isn't it incredible that fractals could be a form of therapy? Moreover, the complexity of our neural networks can also be described using fractals. The way our neurons connect and communicate with each other follows patterns that, like other biological structures, resemble fractals. Research in this field seeks to better understand how the brain works, which could lead to significant advances in the treatment of neurological diseases. Imagining that the key to understanding our brain could lie in fractal mathematics is truly astonishing. Over the years, medicine has used various tools to unravel the mysteries of the human body. However, the incorporation of fractals into this equation has opened new doors. Scientists are beginning to understand that, just like in a fractal, where each part reflects the whole, the small interactions within our bodies can have a significant impact on our overall health. This conclusion invites us to rethink some of the ways we understand biological systems. Fractals also teach us about the dynamics of diseases. By studying how certain conditions spread through a population, researchers have begun to apply fractal models to predict outbreaks and epidemics. This is crucial for public health, as it allows decision makers to act more quickly and effectively. Who could imagine that a mathematical concept could be so useful in the fight against diseases? Although fractals may seem like a complex concept, their application in medicine demonstrates that mathematics can be a powerful ally in the search for solutions. As we continue to explore these intersections between science and mathematics, we are likely to discover even more ways in which fractal patterns can help us understand and improve our health. The fascination with fractals in the medical field is a reminder of the interconnectedness of different disciplines. Mathematics, biology, and medicine are not isolated fields. Rather, they are intertwined in a complex tapestry that reveals how life works. With each new discovery, we get a little closer to unraveling the mysteries of our bodies and perhaps finding new ways to cure diseases that today seem insurmountable. Finally, the future of medical research is full of possibilities. As we continue to discover more about fractals and their relationship with biology, the horizon of new treatments and therapies expands. Mathematics, far from being just numbers and equations, presents itself as a language that can help us understand the complexity of life itself. And on this journey, fractals are undoubtedly one of the most fascinating tools we have at our disposal. Why do fractals have so much to do with our perception and emotions? The connection between psychology and fractal patterns is a fascinating topic. Since ancient times, humans have been intrigued by the beauty of repetitive forms found in nature. But what is it that truly attracts us to these patterns? Perhaps it is their infinite complexity or the way they make us feel. The psychology behind fractals offers us interesting answers. Fractals are more than just simple geometric figures. They are a representation of nature itself. When we observe a tree, for example, we don't just see its trunk and leaves, but we perceive how it branches out in repetitive patterns. This repetition found in the arrangement of branches, leaves, and even in the shape of the bark, evokes a sense of familiarity and comfort. This leads us to ask, why are we so drawn to these forms? The answer may lie in how our brain processes visual information. Studies suggest that humans have an innate preference for patterns that are balanced and symmetrical. Fractals, with their self-repetitive nature, offer just that. When observing a fractal landscape, our brain feels satisfied as if it is seeing something it understands and recognizes. But is that the only reason we like them? The connection between fractals and our emotions goes beyond mere aesthetics. There is evidence suggesting that exposure to fractal patterns can have a positive impact on our mood. Imagine walking through a forest surrounded by trees that branch out in complex shapes. This type of environment can reduce stress and promote a greater sense of well-being. Could it be that the fractal nature of these environments contributes to that inner peace? Let's also consider the role of fractals in psychological therapy. Some therapists use fractal art as a tool to help people explore their feelings and emotions. By creating or observing fractal patterns, patients can unlock repressed emotions and find ways to express them. Isn't it amazing to think that a simple pattern can facilitate such a deep connection with our emotions? Human perception of fractals is also related to how we interpret chaos in our lives. Often, the world can seem disordered and chaotic, but fractals teach us that within that chaos there is an underlying order. This idea can be comforting, especially in times of uncertainty. How can a mathematical pattern influence our understanding of the world? Fractals also have implications in design and architecture. Many architects have begun to incorporate fractal principles into their works, creating spaces that resonate with nature and human psychology. These designs are not only visually appealing, but also foster a positive emotional experience for those who inhabit them. What if all the spaces we live in took into account the psychology of fractals? The relationship between fractals and our emotions leads us to reflect on the meaning of beauty. Is beauty something subjective, or are there universal principles that govern it? Fractals seem to suggest that there are patterns in nature that we can all recognize and appreciate, regardless of our cultural or personal background. This opens an interesting debate about how we define what is beautiful. Moreover, fractal aesthetics can be especially powerful in the realm of music. Composers and musicians have explored fractal patterns in the structure of their works, creating melodies that resonate deeply with our senses. Listening to music that incorporates these patterns can evoke intense emotions, taking the audience on an emotional journey. What if music and fractals are more connected than we think? At the end of the day, fractals invite us to explore the intersection of mathematics, nature, and psychology. They remind us that, although the world may seem chaotic and disordered, there are patterns we can recognize and appreciate. On a deeper level, they offer us a new way to view our own existence, suggesting that, like fractals, our lives are filled with repetitions and variations that make us unique. The beauty of fractals lies in their complexity and their ability to resonate with our deepest feelings. They teach us that despite the diversity of human experiences, there is a common structure underlying everything. By understanding this connection, we may find a greater sense of peace and harmony in our lives. So the next time you encounter a fractal pattern, whether in nature or in art, take a moment to reflect on what it truly means to you. What emotions does it evoke? What thoughts does it provoke? In the end, fractals are more than just simple shapes. They are a window into our own humanity. Fractals invite us to reflect on the nature of infinity and the complexity of the universe. But what philosophical implications can we draw from these intriguing patterns? For many, fractals represent a gateway to fundamental questions about existence, chaos, and order. Could it be that by exploring fractals, we are also exploring aspects of our own consciousness? The idea of the fractal leads us to question how we perceive reality. Often, our view of the world is limited to what we can see, touch, or measure. However, fractals show us that there is a beauty and complexity that escape our everyday perception. How can something as simple as a snowflake or the branching of a tree contain a pattern that repeats at different scales? This phenomenon suggests that the universe is interconnected in ways we do not yet fully understand. In philosophy, there is a concept called the idea of infinity. This concept leads us to think about eternity and what lies beyond our understanding. Fractals, with their infinite nature, act as a mirror of our own cognitive limitations. If each fragment of a fractal can reveal the whole, what does that mean for our quest for knowledge? The notion that infinity can be present in the finite invites us to rethink our understanding of time and space. The relationship between chaos and order is also central to the philosophy of fractals. We often believe that chaos is the absence of order, but fractals demonstrate that within chaos there can be intricate structures and surprising patterns. Is it possible that our lives, often filled with uncertainties and disorder, also contain an underlying backdrop of order? This idea is comforting and invites us to find meaning even in the most chaotic moments. Throughout history, many philosophers have explored the duality between the simple and the complex. Fractals are a reminder that simplicity can give rise to complexity in unexpected ways. A simple set of rules can generate an entire universe of patterns and forms. What does this say about the potential of our own actions and decisions? Perhaps in the small acts of life there are also much larger repercussions than we can imagine. The concept of fractals is also connected to the idea of aesthetic perception. The fractal beauty we find in nature and in works of art can evoke deep emotions. Why are we so drawn to these forms? Could it be that our connection to the fractal is rooted in the way we perceive the world? When observing a mountainous landscape or the way clouds move, we feel a visceral connection. This connection may reflect our desire to understand what surrounds us. The philosophy of fractals also reminds us of the importance of exploration. Just as a fractal expands infinitely, so does our curiosity. Every answer we find can lead to new questions. Are we willing to accept that we may never have all the answers and that this is part of the journey? The pursuit of knowledge is, in itself, a fractal, where each new discovery opens a new path of exploration. In this sense, fractals teach us about humility. We are not the only ones in the universe. We are part of a larger whole, an interconnected system that extends beyond our understanding. How can we reconcile our individual experiences with the vastness of the cosmos? Fractal philosophy invites us to see our lives as a point in a vast web of connections, where each action has an echo in the grand design. When considering fractals and philosophy, we can also reflect on the nature of time. Fractals, being repeating patterns, suggest that the past, present, and future may be intertwined in unexpected ways. Is time a simple linear thread, or rather a tapestry of interrelated interactions and events? This idea can change the way we understand our own stories and experiences. The notion of the fractal also invites us to question the idea of perfection. In a world where we often seek perfect forms and ideal outcomes, fractals remind us that beauty can be found in imperfection. Could it be that our pursuit of perfection distances us from the wonders of diversity and uniqueness? By embracing imperfection, we may find a new way to appreciate what surrounds us. The philosophy of fractals is also linked to ethics. If everything is interconnected, what is our responsibility towards others and the planet? This interconnectedness calls us to act with greater awareness and consideration, recognizing that our actions have an impact beyond the immediate. Are we willing to be mindful of our choices and how they affect the broader web of life? Finally, reflecting on fractals is a journey towards self-understanding. By exploring the patterns that emerge in our lives, we can discover more about ourselves and our relationship with the world. What do fractals teach us about our own experiences, aspirations, and fears? Perhaps by understanding fractals, we are also on the path to understanding the mystery of our existence. Thus, the philosophy of fractals not only invites us to think about abstract concepts, but also offers us a framework to explore our own humanity. It challenges us to look beyond the surface and find meaning in the complexity of life. As we delve into this fractal universe, we are not only exploring the world, but also navigating the labyrinths of our own mind and heart. Have you ever looked at a snowflake or a leaf from a tree and wondered how those shapes can be so intricate and repetitive? Fractals offer us a fascinating window into that complexity, but today we are going to explore a different aspect: how we can create fractals ourselves. Can you imagine being able to design infinite landscapes and amazing patterns with just a few clicks in a computer program? Creating fractals may seem like something reserved for mathematicians or programmers, but in reality, it is accessible to anyone willing to experiment. The first thing we need to understand is that a fractal is more than just a simple image. It is a process, just like following a cooking recipe. There are steps to follow, but there is also room for creativity, ready to become a fractal chef. To begin, let's talk about a very popular tool: fractal generation software. There are several options available. Some are free and others are paid. Programs like Apophysis or Mandelbulb 3D are excellent for beginners. But what makes these programs so special? The key lies in the mathematical formulas they use. But don't worry, you don't need to be a math expert to start creating. These programs allow you to play with parameters and see in real time how the images change. Imagine that every change you make in the program is like adjusting the ingredients in your recipe. A little tweak here, a bit more of this parameter there, and suddenly a new pattern appears. Isn't that exciting? You'll be amazed at what you can create simply by experimenting as you dive into the process. You will discover that there are different types of fractals. Some are simpler, like the famous Sierpinski triangle, while others are more complex, like the Mandelbrot set. But how do we start? A good way is to choose a simple fractal and then start adding details. For example, when working with the Sierpinski triangle, you can start with an equilateral triangle and then keep dividing it into smaller triangles. Each time you do this, you will see how complexity emerges from simplicity. You can also play with colors. Fractals are not just shapes, they can be vibrant and full of life. By applying different color palettes, you can transform a basic image into a visual masterpiece. Try using warm tones in a fractal and see how it changes the feeling it conveys. Have you ever wondered how a simple change of color can alter your perception of an image? It's fascinating to think that fractals are not limited to computers. You can create fractals by hand, using pencil and paper. You can draw a simple fractal like the Koch snowflake, which starts with a triangle and transforms into a shape that looks like a coastline full of peaks. This process is like watching how a small idea can expand into something vast and complex. Now, if you're feeling bold, why not try creating a fractal from a mathematical equation? This may sound intimidating, but there are many online guides that can help you. One of the most famous is the Julia set equation. This equation produces patterns that repeat in a hypnotic way. Although it may seem like a maze at first, each attempt is a step towards something truly unique. As you explore fractal creation, it's important to remember that there is a global community of enthusiasts. You can share your creations on forums and social media and receive feedback from others. This exchange can be incredibly motivating. Seeing what others have created can inspire you to try new techniques and styles. Have you ever felt that spark of creativity when looking at someone else's work? Creating fractals also opens the door to collaboration. You can work with friends or family, turning the process into a fun and educational activity. Who knows? Maybe together you can create a fractal that combines each person's style, forming something completely new. Creativity multiplies when shared. Don't forget that every fractal you create is a representation of the beauty of chaos. Often the most complex patterns emerge from the simplest rules. Isn't it amazing to think that from a basic idea, you can generate infinite variations? The next time you look at a fractal, remember that behind that image is a creative process that reflects the very nature of the universe. At the end of the day, creating fractals is a way to explore not only art and mathematics, but also your own imagination. So what are you waiting for? Go and start creating. The beauty of fractals is waiting to be discovered by you. And each image you generate will be a step on your personal journey through a world of infinite patterns. Will you dare to dive into this creative adventure and let your mind expand along with the fractal universe? Fractals are not just a visual phenomenon, they can also be a way to understand the complexity of the universe. Did you know that the structure of the cosmos could have a fractal design? The idea suggests that, just like in fractals, where a pattern repeats at different scales, the universe could be organized in a similar way. But how is it possible that something so vast and seemingly chaotic can follow a pattern? The notion that the universe may be fractal is supported by the observation of the distribution of galaxies. Imagine you are in a vast ocean, and in every wave that forms, you see a small reflection of what happens in the entire ocean. Similarly, when we observe the arrangement of galaxies in the universe, we notice that they cluster into larger structures that resemble repeating patterns. Isn't it fascinating to think that in every corner of the universe, we might find the same organization? Let's think about a tree. When we look at a tree from afar, we see it as a unique entity. But as we get closer, we notice that its branches divide into other branches, and those in turn into smaller branches, creating a growth pattern that repeats. This same principle can be applied to the way galaxies cluster. Some theories suggest that if we looked closely enough, the structure of galaxies might reflect that same self-similar pattern of fractals. The idea that the universe could be fractal raises intriguing questions. What other patterns might we be missing by observing the cosmos only on a large scale? If fractals are a way to describe nature, could they help us unravel the secrets of the universe? Science has shown us that there is much more than meets the eye, and fractals could be a key to understanding it. Moreover, fractals offer us a way to explore the infinitely small and the infinitely large. At a subatomic level, the patterns of energy and matter may also exhibit fractal characteristics. Just as a snowflake has a unique design but follows a pattern, the basic components of the universe might follow similar rules. What does this mean for our understanding of existence itself? Imagine the universe as a gigantic hologram where each part contains the information of everything else. If fractals are the key to understanding this phenomenon, we might be closer to grasping how everything works in the cosmos. What a wonder it would be to unravel the mystery of creation through these patterns. As we continue to explore, it's interesting to consider how chaos theory intertwines with these ideas. In chaotic systems, small variations can lead to significant differences in outcomes. This suggests that the universe is not just a predictable mechanism, but a place where uncertainty and beauty intertwine. Could it be that the very chaos we observe in nature is a reflection of the complexity of the fractal design of the cosmos? Let's talk about seismology. When scientists analyze the movement patterns of tectonic plates, they encounter structures that can also be described using fractal geometry. Mountains, the arrangement of rivers, and the formation of coastlines follow patterns that repeat at different scales. Could we apply this concept to other natural phenomena and uncover more hidden patterns in our environment? The idea that the universe has a fractal design could also open the door to new ways of thinking about life itself. Theories about evolution and biology could benefit from exploring how fractal patterns influence the diversity of life. Could it be that the way species adapt and evolve follows a fractal principle? These types of questions are not only fascinating but could also revolutionize our understanding of biology. As we move into the future, research on fractals and their relationship with the universe becomes increasingly relevant. With tools like advanced telescopes and computer simulations, scientists are on a constant quest to discover new patterns. What discoveries await us in the coming years? Human curiosity and technology are pushing the boundaries of what we know, and fractals could be one of the keys that lead us to surprising answers. Reflecting on all this, it is evident that fractals are more than just a mathematical concept. They offer us a window into understanding the complexity of our universe. Just as a fractal never repeats exactly the same way, the pursuit of knowledge is a continuous journey. In the end, every discovery we make about fractals brings us a little closer to understanding our own existence in the vast cosmos. Imagine a future where we can apply these fractal principles not only to science but also to philosophy and spirituality. What new questions will arise as we combine these concepts? The intersection of the mathematical and the philosophical could open new avenues of exploration that we could never have imagined. In conclusion, as we look toward the universe and its possible fractal structures, we realize that every small discovery matters. Every pattern we identify can be one more step toward understanding who we are and our place in the cosmos. Thus, fractals are not only a feature of the world around us, but an invitation to keep exploring, questioning, and marveling at the complexity of life. What if I told you that fractals, those geometric wonders that seem to emerge from a mathematical dream, have the potential to revolutionize many areas of our lives? Science and art have only been the beginning. Today, we will explore the frontiers of human knowledge and how fractals could be the key to unraveling still unresolved mysteries. Imagine a world where nature is not limited to what we see at first glance. Fractals have the ability to reveal hidden patterns, structures that repeat at different scales and help us understand complex phenomena. What role will they play in the future of science? As researchers delve into the use of these patterns, the possibilities are endless. Let's move to a fascinating realm: technology. Have you ever considered how fractals could change the way we interact with the digital world? From image compression to computer graphics creation, fractals are at the heart of innovations that make our daily lives more efficient and visually stunning. The ability to generate detailed images from simple formulas is an open door to new forms of art and communication. What else could we create if we better understand these patterns? In the field of biology, fractals are also making their mark. Did you know that the way tree branches grow or how veins are distributed in a leaf can be described using fractal mathematics? This intersection of biology and mathematics not only helps us better understand life, but also opens the door to new forms of medical research. What new discoveries await us in this field? The study of chaos and fractals has begun to blur the lines of what we consider predictable. In a world where everything seems to be in constant change, will it be possible to find order in chaos? Fractals teach us that often what is chaotic can have an underlying structure. This could change the way we approach phenomena like weather or even human behavior. Speaking of weather, the relationship between fractals and meteorology is intriguing. How can these patterns help us predict the weather? The complexity of climate systems can be overwhelming, but by applying fractal models, scientists are beginning to make significant advances in understanding these phenomena. Could this mean that one day we will be able to predict the weather with astonishing accuracy? In the financial realm, fractals are starting to play a crucial role. The economy is a dynamic and often chaotic system. What if the study of fractal patterns could help us anticipate economic crises or financial bubbles? Economists are beginning to apply these concepts to model markets more effectively, which could change the way we invest and save. The connection between mathematics and economics is more alive than ever. Music has also been influenced by these patterns. How can the structure of a musical composition resemble a fractal? Some composers are experimenting with patterns that repeat at different scales, creating pieces that are both innovative and deeply resonant. If fractals can be the key to understanding beauty in music, what other forms of art could benefit from this understanding? In medicine, the use of fractals has begun to offer new perspectives on cell growth and disease development. Could fractals help us better understand tumor growth? As researchers continue to explore these connections, the hope is that fractals not only help understand disease but also lead to more effective treatments. Psychology is also benefiting from research on fractals. Why are we attracted to certain patterns? Fractal aesthetics have been shown to have a positive impact on our emotional well-being. Studies suggest that exposure to fractal structures can reduce stress and improve concentration. Could it be that beauty itself is written in the language of fractals? Reflecting on the future, it is clear that fractals are a bridge to knowledge across multiple disciplines. What discoveries await us if we continue to explore these structures? The possibility that fractals will continue to unlock secrets about the universe is exciting. From astronomy to philosophy, the impact of fractals could be profound and transformative. As more researchers and artists venture to explore the fractal world, will we be able to see beyond what we know? Human curiosity is a powerful force, and by integrating fractals into our understanding, we could find answers to questions we have yet to ask. The future of fractals lies not only in science and technology, but also in our way of understanding the universe. As we continue this exploration, let us remember that fractals are more than just mathematical patterns. They are a window into the complexity and beauty of life itself. The adventure is just beginning, and the possibilities are as infinite as the fractals themselves. Fractals are much more than simple visual patterns. They are a gateway to understanding how the universe works. As we have explored their presence in nature, art, technology, and many other fields, we have seen that fractals are a common thread that weaves together diverse disciplines. But why are they so important? The answer lies in their ability to model the complexity of the world around us. When we look around, we find fractals everywhere. From the way the branches of a tree branch out to the way leaves are distributed on a plant. These repetitive patterns teach us about natural organization. The beauty of fractals lies in their simplicity. From simple mathematical rules, extremely complex structures emerge. But how does this translate into our daily lives? How can they help us understand phenomena that seem chaotic? Let's consider the weather for a moment. The behavior of the atmosphere is notoriously complicated, and yet fractal models have proven to be a valuable tool for predicting weather patterns. Just as an artist uses brush strokes to create a masterpiece, meteorologists use fractal models to map the movements of air and moisture. But what if these patterns could also be applied to other areas, such as economics? Financial markets may seem like total chaos, but fractals offer a way to analyze and forecast trends. Although there are no magic formulas, fractal theory can give us clues about buying and selling behaviors. Isn't it fascinating to think that, in some way, everything is connected? From mountains to human behavior, the fractal principle is a universal truth. As we reflect on art, it is interesting to see how fractals have inspired artists around the world. The repetition and complexity of these patterns have become a powerful means of expression, from music, where fractal structures can shape compositions, to painting, where artists find beauty in repetition. Fractals are at the heart of the creative process. But what does this mean for our aesthetic perception? The connection between fractals and our emotions is astonishing. Studies have shown that fractal patterns can influence our well-being. By observing fractal images, our minds can find a kind of calm and order. This raises an intriguing question. Could fractals be the key to improving our mental health? Looking to the future, it is evident that fractals will continue to play a crucial role in science and technology. With each advance in research, we discover new applications, from medicine to biology. The way cells organize and grow can also be understood through the fractal lens. Is it possible that these microscopic structures could impact our understanding of complex diseases? We cannot forget the philosophy underlying the study of fractals. The idea of infinity and the complexity of the universe lead us to question our own place within it. Each fractal is a reflection of the whole, a microcosm that invites us to explore beyond the surface. This quest for meaning is an intrinsic part of the human experience. As we pause to think about what we have learned about fractals, it is essential to remember that these patterns are not just a mathematical curiosity. They are, in essence, a way of seeing the world. They teach us that beauty and complexity can arise from the simplest rules. Isn't this a reminder that often in life the complex can be more accessible than it seems? In conclusion, fractals offer us a unique perspective on reality. They show us that although the world may seem chaotic, there are underlying patterns and structures that order it. At the end of the day, so fractals are a celebration of the interconnectedness of all things. They invite us to look closer, to explore what lies behind the visible, and to appreciate the wonder of nature, art, and science. The next time you observe a tree or a snowflake, remember that you are witnessing a fractal in action, a tangible representation of the beauty of the universe.